I'll turn the light on so we can see it. Okay.
Door jam is not allowed. Door jam is not allowed. Door.
No, these doors, they're self-closing doors. You can't pop them open. Part of the fire rating. Okay. What is it? Let's see how you go. What do you think it might be? Any ideas? No? Transformer. Yes. This is it's a kiosk substation, so it's a type of transformer. This is part of the emergency power supply system. So what we saw before, the surface chamber substation, that's part of the main electrical supply that comes from the street. This one's part of the emergency power supply. We're not running on emergency power at the moment, so this isn't on. The emergency generator that we have here on campus is quite a long distance away from where we need the power, which is to this main switchboard room. So because of the long distance, at the generator, they increase the voltage to 11,000 volts. Send it underground across campus through this large orange cable that you can see on the wall to this transformer. This transformer steps it down to 415 to the main switchboard room that we just saw there. So this is not a typical piece of equipment. Well, it's not a typical transformer, it's not a typical piece of equipment that you might see, because ideally in your building, you'd want your generator to be closer to your switch room, so you haven't got that issue with distances. Yeah, and this will only go on when the emergency generator turns on. I've been at Bond for 4.5 years, and I've seen that generator go on once. That's it. So, yeah, equipment that you have to pay for and you have to maintain, just in case. Just in case equipment. Okay. So we'll head over to the lift motor room when everyone's had a look in here. Lift motor, no touching, or you might lose a finger, okay? But you are welcome to go in there, just, yeah, don't touch it. It's safe, as long as you don't touch. So this is the lift motor room for this lift. This is it's quite a short building, it's only 4 stories. So this is quite a big motor for a lift that doesn't go very far. But this is the technology that was needed 30 years ago. This is the original lift motor. And Ali's going to talk to you about lifts and what he'll talk to you about that if this lift gets replaced, which it probably will soon, it's getting quite cold. You won't need a motor of that size. You'll actually be able to use a small motor that fits inside the lift shaft. This motor is not just actually inside the shaft. Yeah, they're so small now. And we don't need any great speed. This is actually really slow. The blue panel that you can see on the right, to the door, the sub-switch board. So the electrical power that's come from the main switchboard room, 415 volts to here, and then broken down to look after the different elements within it. We'll just move over, guys, so we can get through. The orange panel you can see is, there you go. turned on. Okay, so that lift's moved, right? Wait again until she closes it. And there it goes again when it's on the move. It's pretty loud. That's when you don't want to touch it. And the orange panel is the control of the exhaust. So you can see this small duct coming out of the wall there. So there's an exhaust point in the wall inside this room drawing hot air out. You can imagine if that motor's running a lot, it's going to get quite hot in there. And there is an opening down the bottom which is drawing in cooler air. The blue panel that you saw just to the left of the door, that's the control panel. So when you press the button, that turns on. Is located up there. So they've had to think about how do we get this motor out when it needs replacement. Not really an accessible space to bring in a crane and some lifting work, so they will use that steel bar. It has 3T written on it, so it's got a 3-ton weight limit. And they will use that as a hoisting mechanism. So you put a cable over the top of it and they can lift up the motor, put the motor onto a trolley, be able to wheel out. So they had to plan for that. Not an easily accessible location. Okay, did everyone get a look in there? Yeah. Nice and quiet. This room is usually very loud. Alright, let's do the what am I? What's the green thing? Sorry, it's part of the HVAC system. It's a chiller. So there's actually 3 chillers in here. There's 2 more hiding behind that big one. They're not on at the moment. On the Bond campus, we have 2 mechanical plant rooms like this one. We have another one underneath building 6. This is a warm day. We would certainly need cooling in some of the rooms. So the chillers over underneath building 6 would be running at the moment. That's why these ones aren't on. So depending on the demand, we've got 6 chillers in total on campus. Which one goes on depends on the demand that we have. You can see those busways that we saw earlier in the main switchboard room. So 415 volts of electricity coming from the main switchboard room to this sub-switchboard for this room. You can see chiller 1, chiller 2, there's the exhaust fan control. They're broken down into the various components within this room. This is part of the control system for the HVAC. So, you know, it's just like kind of computer bits, really. So if you think about how the HVAC system needs to work, it's all automated. No one's turning it on. So the programs are in, what times it will operate, what temperatures it will operate at. The thermostats located within each of the zones are measuring the temperature, feeding that back into the control system, which then decides where chilled water needs to be sent, which chiller needs to be turned on. So all of the mechanical plant rooms that you see will have units like this, and they're part of that control system, building management that we have. So I said before that we have 2 rooms like this on campus. So what we have running around campus is a big ring loop. So we have pipe work that runs all the way around campus and just constantly circulates chilled water around. And then each building has its own pump and can draw water out of that ring loop that goes around. The white pipes that you can see, and also the silver pipes, they have the chilled water inside them. So they're insulated pipes to keep that chilled water at 5 degrees. You can see that there's 2 pipes connected to each chiller, so 2 white pipes. So outgoing, so the chilled water going off to the air handling unit at 5 degrees, and then the water that comes back from the air handling unit, which is usually around 10 degrees, so it can go back through that evaporator side of the chiller again, before it goes back to the air. We've also got green pipes in here. They're your condenser water. They're connected to the cooling towers, which are located outside. Each of the chillers has 2 green pipes connected. So water going out to the cooling tower, water coming back in. You can also see on this left-hand side, these are pumps, and each chiller has 2 pumps. One pump's for the chilled water, the other pump is for the condenser water. Wander down through this way.
Hold on.
Large exhaust fan in this room. I've been in here on days when all of these chillers are running and it's about 32 degrees in here, so it gets very hot. So that's just extracting some of that heat. See, it's running pretty slow at the moment. The pumps that we have over here, this one is actually running. So I said before we've got a ring loop that runs all the way around campus, and the chillers that we have are feeding the chilled water into that loop. This pump is just for building 4. So this pump is taking water from that ring loop and delivering it to the air handling units for building 4. So every building on campus that's connected to this chilled water system has these pumps to draw off what it needs from the system. Head over this way. Hot water? It's a heater, it's not a boiler. So we actually don't have a hot water boiler here on campus. So we're not producing hot water for space heating. We find that we have very little need for heating here on campus. So if you think about it, today there was 24 of you in the classroom. We can fit up to 40 inside that room. What you probably need is some cooling by the time everyone's been sitting there for a while. So we do have, within the ductwork, we do have small electric heaters in some of the buildings, but we really only need that early on in the morning. So yeah, this is a hot water unit, a hot water heater, domestic hot water. So this is producing hot water to use in the hand basins, in the kitchen sinks and building floor. So it's a tank unit, holds 315 litres of water. We don't really need a lot of hot water. If you think about when you did the assignment, office building with no canteen, it's essentially how our buildings function. No one's cooking the dinners in these kitchens that we have in these buildings, except over in our commercial kitchen in building 6.